Welcome to the holiday party. Yeah. So my name is Moshe Zadka, and I want to talk to you about why you should use Twisted as your WSGI container. So these are all from the project documentation. This is not like my critique of them. This is their critique of themselves. Sometimes with capital letters, do not use this server in a production setting. Sometimes it's do not use the built-in development service in production. Or sometimes the development service is not intended to be used on production systems. I guess you can if you want to or something. And literally this was limited by the size of the slide. I have 5 more of those that didn't make the slide. This is just a popular, do not use those in production setting servers. So why use one server in development and one server in deployment, right? So let's just to be concrete and show you how easy it is. This is an example Pyramid app. I use Pyramid just because a lot of people know Flask and Django, so I want to use something you don't know. Pyramid is pretty nifty. I like it. The new PyPI is going to be written in it. So Donald stuff turned me on to that. Anyway, it returns hello world like every app I make in every web server because I don't really write web apps. But here's how easy it is to run it. Right? Literally, this is all you need to do. And even the Python path equal dot is something you really shouldn't do. Even in development, you really should install with setup py. But if you really don't like writing setup py because it's against your religion or anything, you can still do that, right? So there's no reason to use the internal Django thing or the internal Pyramid thing or the internal Workzorg thing or the internal Flask thing. No, do not use it in production because then you'll forget to not use it in production. You'll test it. And I have seen people who ignore that warning, like the GNU health stuff. One of those, I think it's the Workzorgs, do not run in production one. But I don't remember which one, but it's one of the do not run in production ones, because, why not? So don't do it in development, and you definitely won't do it in production when you move to production from development. Then you don't have the problem that you have weird bugs in production that you don't have development because the WSGI is slightly different and it returns a dictionary and it doesn't encode something or it doesn't code something and the problems don't reproduce. So just use the same thing, and Twisted is good for the same thing because it's pretty easy to use. So you've seen. So then you get a lot of nice features in your web server. You get HTTP2 support. Even if you don't use any of the sophisticated servers, just the fact that now browsers can get a bunch of stuff in parallel and stuff like that, that's pretty nifty. Especially if you have a Ajax heavy thing that will connect to your server multiple times. You get SSL support, which is also pretty nifty, so you don't have to run Nginx in front of it, adding new and interesting security holes to your deployment configuration. You have Let's Encrypt support, which you should probably use because it's one of the best supported and honestly one of the best around certificate authorities. So not only do you get SSL, you get just a really easy way to use SSL that you almost don't have to configure. And you get static file support. So again, you don't have to add another fun thing to your production stack which will break in funny ways because it's written in C and probably will lead to an exploit at some point. And the nicest thing is that you don't have to program INI files. And this is really nice because you already know Python, right? You already know the configuration language. So you literally can write your configuration in Python. Not in a DSL written on top of Python, just write Python. You probably already are doing that anyway. So Twisted is written in pure Python, so you don't have any extra C stuff. You can use the same stuff on your development and production setup. You can configure it in Python. You get all the SSL and static file support built in, so you don't have to run 5 different things on top of it and to the side of it and complicate your configuration. That's it. Thank you very much.
Thanks, Hai. Thank you, Grace and Hai, for setting this up. It's a real pleasure and an honor to have this group of people in this room. When we opened the reactor, it was something that was top of mind, the Python meetup. We really like this group. We like what they do, and we want to get them in our doors. So we're happy to have you guys. My talk is about Linux app services on Azure. I don't have a Mac. How do I enter full screen? There we go. Okay. This is my Ultimate Frisbee team from Beach League. If you want to play Ultimate, I'd love to come hook you up with some pickup, some tossing. Somebody back there. It's a fun way to get outside. This is Azure. This is our new portal. It's much better than our old portal. Most people don't know, but we support Linux, IaaS, all sorts of good stuff in there. We're rapidly developing on it. It's really cool to see what the engineering team is doing. One of the most recent things we've been doing is our app services with Linux. We used to have kind of like a NT-based app services model. So hosting Python was really a pain. It was lots of configuration files, and if you were developing on a Mac or a Linux machine, you weren't really sure if the libraries were going to be available. But now we've got Linux-based app services, and the coolest thing about that is you're able to just point it to a Docker image and then just deploy it right from there. So you've got that kind of Docker local deployment, and then you just push it up and we host it. So I found this Docker Flask on Docker Hub, and I was like, this is my first time looking into it. Earlier this week, Hai was like, hey, do you want to give a lightning talk? And I was like, sure. And so I was just like, all right, Docker Flask, look up Docker Hub. I threw in the tag to that part of the hub, clicked OK, it deployed, and it worked first try. That never happens with Python on Azure if you've tried it before. So that's really good news, and it was fast, and it was stable, and I was really excited. So I was like, all right. I didn't even have time to look at the code. I just literally just grabbed the tag, threw it in there, and it worked. But here's the Docker file. We can see we're grabbing from Ubuntu, so it's Linux-based. We're setting up NGINX. We're running it up. We're configuring the files, running requirements.txt, and then it just exists. So I was like, what else can I do? This is sweet. What else can I spin up? Ruby. So here's the Ruby Docker file, super small. This one's using Puma. Just setting up a configuration port and then running with it. Checked out, no problem. Sounds good. It's showed me my Docker file in here. I just pointed it to one that I had made, and no problem. How about Node? Here's the Docker file for Node, super small, but just kind of to prove the point that it's all the same stuff. Worked, no problem. So it's really exciting seeing this kind of build from Microsoft. The last 2 years I've been working for Microsoft. It's been always a pain helping people with stuff, and now it's not a pain. So it's kind of exciting. The teams. This is the roadmap that they've got ahead of themselves. Currently, it's in preview, so not ready for production, but ready for a good trial. One of the cool things they're trying to do is individual SSH into each Docker image, or like if you run a whole Docker cluster through this, you can actually SSH in each individual one. Another really cool thing they're doing is slots, so like Docker slots. Like if you have a production and a development and kind of like a load balancer, you can go from slot to slot. So some really neat stuff there. Let me know if you're interested. I'm on Twitter. That's probably the easiest way to contact me. Thanks for having me.
Good evening, everyone. So who's excited to learn about a nice mystery that I solved earlier this year? Cool. Yeah, so let's get started. So I was rewriting my company's API server, and I ran into a pretty strange bug. So first things first, it's related to Stripe. Or rather, it's related to the endpoint where we update credit cards. So for those who are unaware of Stripe, it's a payment processing service which makes charging people really, really easy on the web. So the way Stripe essentially works is you have a mobile app or a JavaScript application on the front end, and where people enter their credit card information in HTML forms. So the good thing about Stripe is that you don't have to store your users' credit card information in your servers. So what Stripe does is it collects the credit card information from the HTML forms. It sends a request to the Stripe front end, and the Stripe front end returns a single-use token back to your front-end JavaScript application. It looks something like this, and your front-end application or your mobile app then just needs to send this token to your back-end server. And all your server will have to do is just verify this token with Stripe, and a Stripe customer is created. And all you have to do is store this customer in your database, which means you don't have to store the credit cards, which is a pretty cool thing. Except I was kind of seeing this bug where I was getting a message back from the Stripe server saying that the token did not exist. So a front-end application was sending a token to me, and when I was trying to verify the token with Stripe, I was getting this error back. So the good thing is that we have Sentry, and you can actually look at logs. And so the front-end engineer was telling me that he was actually sending me the correct token to the API server. And the API server was getting the right token, so why was Stripe sending me this error? So the reason was because the token was getting truncated. So when I was making the call to the Stripe API, the last 2 characters of this token was getting truncated. So why was that happening? So, okay, so this slide says debugging in the wild, right? Which is kind of my preferred way of debugging. And usually the first 3 kind of like get me to where I want, which is I tried to reproduce with a failing test. That didn't work. I try, print statements, they're always cool. They always tend to work. That didn't work either. You tend to look at logs. That did not work either. So let's actually look at the code that was failing. So don't actually mind the private methods. Someone liked Ruby a little too much, but it's actually fairly simple code. Like you're getting some data, you have a method called update user account. You're seeing if this credit card token is in the data you're getting. If yes, you're just calling another function, which then just makes a call to Stripe. So we're just kind of making a call to Stripe, and what Sentry was telling us was that until this point, I was getting the right data. So why was this call failing? And like I said, I was actually rewriting a server, so the old server was kind of actually working, and the code there was actually very similar. I mean, this code isn't even particularly well written in that, this whole Stripe call is not even like in a try except block. So this kind of like really bad code was working, but the good one wasn't. So why could this be happening, right? So what was the difference between the old server and the new one? Well, for one thing, the new Python application was Dockerized, right? The snake oil, Docker is just going to solve everything for you. So could it actually be Docker? So the good thing is that I can spin up a Docker container in development, which I tried doing, and turned out it wasn't Docker. So that was not why this call was failing. Could it be Vault? So Vault is a secret management system. Anyone here familiar with Vault? Well, it's great. So we store our Stripe secret key in Vault. So all we do is read the key from Vault and then use that key in the application. So could it be Vault? Could we be reading the wrong key from Vault? Turned out that wasn't the case either. Could it be Stripe itself? Could there be something wrong with the version of the Stripe library that we were using? Or just something wacky going on? Turned out that wasn't the case either. At this point, I was really clutching at straws. I was like, maybe it's just Ghost. I don't really know why this is happening. It was like, maybe it's Ghost. And then something just struck me. I was like, okay, I think I know what's happening. So it's not really Ghost, but it's the Python equivalent of Ghost, which was Unicode. So everyone here knows, I'm pretty sure everyone here has seen, ASCII cannot encode thing. That's like the standard Unicode error. I mean, I spent my entire previous job just fixing Unicode errors. But the fix was very simple. The fix was just this. So when reading the Stripe key from Vault, because pretty much, not just Vault, but pretty much all libraries and all applications actually don't return back strings. They return back Unicode characters to you. So if you're using PyMongo, which is the driver for MongoDB, it returns Unicode. If you're reading from a database, you get Unicode back. In this case, we're reading secrets from Vault, we're getting Unicode back. And so the fix was simply just turn it to a string and just ditch the Stripe library, just make a call to request directly to the Stripe API, and it works. So what was the lessons learned from this? Unicode errors are kind of hard to debug because you can try with print statements. It's going to print the right thing, and it's kind of really hard to say what's a string and what's a Unicode unless you explicitly go and check for that, which people don't do. And the other thing is avoid library hell. If you can make a call directly to something, just do it. And this is the most important thing: don't pass requests a Unicode string in the data variable. So this bug report actually came up after I fixed this issue. So here's Corey Benfield just saying, so if you have a data dictionary that you want to pass to request, don't use Unicode in there. Make sure that it covers everything to string before. Or you just pass whatever you want to pass, but pass it in the JSON variable. And that pretty much fixes the issue. Thank you, that's all I had.
Cool. So as Hai mentioned, so it's not exactly customary to dedicate a lightning talk to somebody, but I wanted to say thank you to Raymond because, and he has no idea about this, many years ago, I took a workshop of his, and he was kind of sneaky. So it was like an advanced Python workshop, and he told us a bunch of stuff, some niche advanced Python tricks. And I don't remember any of those things. But what stuck with me was that every time he wanted to really prove a point, actually just constantly, he was bringing up the code, the CPython code. And he made it very clear to us. I think the lesson really for us there was that the CPython code base is readable, it's understandable. You should have an instinct to go and read the code. So what I want to do is, in 5 minutes, this is actually kind of an adaptation of an 8-hour seminar series that I do. So in 5 minutes. So, okay, it sounds funny, but I think there's a key 5 minutes in that 8 hours where the students these are typically students who've been using Python for a few years, but who've never opened up the code. Actually, to get a sense of that, how many people here have like pulled the CPython code and read through it and like tried to answer a question through it? Maybe like 20% or something. This is for the rest of you. I think there's this key 5 minutes where we teach where these folk who use Python all day long and are good at it cross this chasm from feeling like users of this language to feeling like they could understand it. That there's nothing in this code base that is particularly complicated that they couldn't with enough time understand. So this is what I'm going to try and convey to you in 3.5 minutes. All right. CPython is just a program. So it's a program that runs programs. So it's a little bit tricky there. Maybe we'll start with the CPython just being a program. And what we mean by that is that it's here. I've just you can grab it from all sorts of places, but I've just pulled the, what do we do here? The Git clone. So I'm sure you've pulled hundreds of things from Git. Pull CPython. And then you can, it's just code, right? So you can just open up your text editor, and here's the Python implementation. And some of it's written in C, a good chunk. So you got to run this make thing, and then it's going to be slower for you because you wouldn't have just built it off stage. But now you have this program, this thing, right? And you can give it a reference to a Python script, or you can hit enter now and use it as a REPL or whatever. But this is just a program. So you know what it means to just be a program, right? Let's just open this up. All right. So actually, I don't even want the canonical. All right. So this is a program, right? This is binary. Don't be fooled by the letters and stuff. This is just so that up the back, you wouldn't be able to read the ones and zeros if it was straight in binary. So this is a hex representation of the binary of this program, and there's a lot of front matter. But let's say that the text segment, the code starts here. That this is the first instruction. So the 32-bit instruction. So when we say this is a program, what we're saying is that it's compiled down into a form where my microprocessor here, specifically my microprocessor, because I built this, can take this first instruction. I'm going to wave my hands a lot. This first instruction, and let's say that this is the, so let's say that this byte of the instruction specifies to my microprocessor that this is an add instruction. And that this is the first register to read from, this is the next, and it's going to write it back here. So what the microprocessor is going to do is going to fetch this instruction from when this executable is loaded into memory. It's going to decode it into these parts, and then it's going to execute it, right? And then the instruction pointer is going to increment because it's an add, and then that's going to be the next instruction, and then maybe that's a branch, and then this is going to be an instruction. Well, we said that's not the text segment. This is going to be the next instruction, and so on. So you know this model, right? Fetch, decode, execute. This is how a program is executed. So why am I talking about this stuff when CPython is not a machine? Well, CPython is not a machine, but it's virtually a machine. You may call it a virtual machine. So basically, this Python executable is a program that the microprocessor can run. And it runs your Python programs. I'm going to show you specifically the way that it does it. So this is just to give you a bird's eye view of this thing. I think really the guts of CPython. And then you can pull the thread on this stuff. You can find a macro that you don't understand and expand and pull the thread and find the stuff. All right, so let's start here. So you know that your CPU has this clock and that it's continually executing these, it's fetching these instructions and executing. That's this. This is your clock, right? You have an infinite loop. Kind of looks funky, but just a loop. And you're fetching instructions, decoding, executing, right? So on each of these cycles. And then where is the fetch happening? Maybe let's say opcode equals, or it's okay, so this you can kind of think of as the fetch, kind of. Again, I'm going to wave my hands a little bit. So it's pulling this opcode out, and some other stuff. And then you have this like decode step, and this is just a like giant like 2,000 line switch statement. And all it's doing here, this is the decode step, right? So you have an opcode just like with your microprocessor. This macro expands to just like case whatever. And so if you have like let's say you have a binary add, you're adding two things together. So you have a program which, actually let me show you this really quickly. So you have a program where you've defined a really fancy function. And you can look at the bytecode for this, right? Right, so this is just like I showed you the machine code. You can just see the bytes. Right, there's the bytecode. So you may see that you have this like opcode 124. You got a fast load and a binary add and so on. And so now when you want to figure this out, you can like look in opcode.h and just find what that is, right? So I happen to know that this is the binary add, but here we go. Where is it? 23 binary add. And then you can come to cval.c and see when this instruction has been decoded by the virtual machine, what does it do to execute? So it does this stuff, yeah? And really 5 minutes was very ambitious for this. So I'm gonna wrap it up basically here. So what I'm gonna say is that like this is the guts. This is what CPython does. This is how it executes your code. This is what it means to be a virtual machine. You can go from your code to the bytecode to cval.c and figure out exactly how your code is running. Very straightforward way. You may need to look up some of this stuff as you like pull the thread and figure out exactly what it's doing. But this is your channel. So I hope this has helped you kind of cross that chasm. I hope you go back to work and feel like I can understand this. If I have a question, I can look at the code. Thank you very much. Very excited about Raymond's talk. If it's anything like last year, it'll be amazing. Thank you. Thanks.